So now we will start with the next topic, small signal half wave rectifier. So here an op-amp is used as an half wave rectifier for small signal analysis. So in this circuit, so we will discuss this circuit, how this circuit converts an analog signal into a pulsating DC, means half wave rectifier. So now here in this op-amp, the non-inverting terminal is connected to the input Vin, and the inverting terminal is connected as a feedback path from the input to the output side. Then there is a diode D1, okay, then a load resistance RL where we are going to measure the output. So now how this circuit works during positive cycle and during negative cycle. So first we will take a positive cycle input signal, okay. So when Vin is at positive cycle, here it acts as an non-inverting operational amplifier. So in that case, so whatever the input positive cycle, the same input will come at the output side with amplified, okay. So at that time the diode D1 acts as a forward biased and allows the output towards the load resistance RL. So that's why, so during the positive cycle we will get the same output which is amplified here. So similarly during the negative cycle of this Vin, so here the output of the op-amp is negative, which is amplified, but the diode acts as a reverse biased during the negative output. So at that time the voltage across V2, that is inverting terminal, acts as a 0, okay. So therefore the voltage V0 here is also 0, that's why there is no output at the negative cycle. So this is how a positive small signal, okay, which is passed through the op-amp using diode and used as a half wave rectifier. So similarly we can discuss this for negative cycle also, only the change is we have to change the direction of diode. So when you change the direction of diode, so again during positive cycle it acts as an open circuit, therefore there is no output here. During positive cycle there is no output, but during negative cycle of the input, diode acts as an closed circuit and allows the output towards the load resistance RL. So that's why during the negative cycle we get the output which is amplified here. So here, so looking at this, we can say that here op-amp can be used as an half wave rectifier for small signal analysis. The same thing here explained, only the change is that the diode can be used as an ideal diode here because the gain of the op-amp is very large, okay. So one thing we can observe here while operating using this circuit, the op-amp may enter into the saturation. Saturation is nothing but either the output becomes plus VCC or minus VEE, then it takes some time to come back to 0, okay. So instead of getting 0 here, it will take some time, then it will come back to 0 practically. So to avoid this, we will use another kind of circuit, okay, which eliminates this kind of problem. So that is here. We have taken one circuit, we call it as negative half wave rectifier, okay, nothing but non-saturating half wave rectifier. So this circuit will prevent the op-amp to entering into the saturation region, either it is plus VCC or minus VEE, because when the diode is open circuit we are expecting 0 at the output. Instead of that, it may enter into the saturation. That can be avoided using this circuit. So in this circuit the only change is that two diodes are connected here, okay, diode D1 and D2, which is connected at the output side. So the same thing, only the change is that here the input is applied for the inverting terminal. So we can also do it for the non-inverting, nothing changes, okay. So here we take an example of inverting amplifier. So when Vin is at positive signal, so this is inverting, the output we will get as a negative cycle. So during positive we get the output as negative, so therefore we can say that diode D1 conducts and D2 is off, because D2 acts here reverse biased, D1 acts as a forward bias, and V0 is measured at the output side, where R1 and RF are used just to measure the gain of the op-amp. So that's why here it will prevent, or first will during the positive cycle, so we will get the negative cycle, so acts as a half wave rectifier. So what happens during negative cycle here? So during negative cycle of V in, here because of inverting terminal we will get a positive cycle here which is amplified. During positive, so here diode D1 acts as a reverse biased, so therefore there is no output voltage, it becomes 0, whereas diode D2 conducts. So that voltage again fed back towards the input side. So thereby diode D2 prevents the op-amp to entering into the saturation, and again it is fed back to the input side. So that's why this circuit is more preferred than the previous one, because it prevents the op-amp to entering into the saturation, which take some time to come back to 0. So this is again we got the waveforms like a half wave rectifier. The same explanation is given here. Just go through this, you will understand. Okay. So this is about op-amp with half wave rectifier to analyze small signals. Okay. So if you have any doubts, you can text me a message. Thank you.